All right, so this is question number 25 from your review, and the first question is to state the hypothesis H0, H1, and choose what kind of test. Is it one-tailed or two-tailed, right? So let's get into it. Now, in order to define the hypothesis H0 or H1, we always need to find the claim, all right? And the claim is right here this time, so it's in the question. Does the average family size differ from the national average, right? So if I want to write this, it's going to be, this is my claim, and differ, all right? So this word, it means different, right? So that the average family size, we see the mean, is different from the reported 3.18, all right? So this is my claim. Now, how can I determine whether it is H1 or H0? Because again, we have different here, all right? This is not an equal sign. This is a different, right? So this can be only H1. H0 is always with the equal sign, all right? So H0 will be the mean equals to 3.18. Now, in order to figure out whether it's one-tailed or two-tailed, we need to graph this statement, which is H1. All right. And the way to graph it, you can be, this is a bell shape. And as you notice here that I am not going to say whether it's a z-axis or a t-axis. I'll get to that later on. But however, I know this is a 0, mean equals to 0. And if I say different, it means you're gonna have two parts that you could be different, either before or either after. And different, that's a two-tailed test. All right. Now, the two-tailed test always is gonna contain the alpha. So these two tails, they should be the total of alpha, which means that this is only half of the alpha, which is 0.1 divided by 2, and this is going to be 0.05, and this is the other half of the alpha, all right? And this is going to be exactly the same value, all right? It's always symmetrical. All right, so let's go back and plug in our information. So the claim is H1. This will be my claim. This is not the claim. H0 will be the mean equals to 3.18. 3.18. And H1 will be the mean is different than 3.18. And we say this is a two-tailed test. Let's check it. And it's good. Now, we are asked to figure out what are the critical values, and all right, separate them with a comma otherwise. Okay, let's see. So now, as you notice here, I did not mention anything about this axis, all right, for the simple reason that we didn't determine yet whether it's a t-test or a z-test, all right? Now, how can I figure out is a z-test or a t-test? First of all, they never gave you the population standard deviation. All right, so let me remind you about sigma and s. So sigma would be equals to the population standard deviation, all right? On the other hand, the s will be the sample standard deviation. They are both standard deviations, all right? So they are both standard deviation. However, one is for the population, the totality of the data, and one is only for the sample, all right? So obviously, this is not given to you. So if it's not given to you, sigma will be unknown. This is enough condition to use the t-test. Every time you have sigma is unknown, you could use the t-test. Another indication as well, we have the totality of the data here is equal to 22 data, all right? So if you count them, it's going to be 22 numbers. So that's again, is n is less than 30, all right? That is enough condition for you to use the t-test again. So it happened here that they are both satisfied, but one of the conditions is enough to use the t-test, all right? So now, we know we are using the t-test, so we can go ahead and put t here. And the question, if I am looking for the critical values, we know there are two critical values. And they are symmetrical, by the way. So one of them is going to be positive, the other one will be negative. So this is a t critical here, and this is another t critical. All right. And the way to look for it I'm going to be using the calculator. So the way to look for it, I always need the left area before the point of the critical point, right? So now, obviously, the left one is easier to find. All right. Why? Because this is already given to you is 0.05. The other piece of information that you might need for the calculator is degree of freedom. And degree of freedom is always going to be n minus 1, which is 22 minus 1, and that's going to be 21. So then I'm going to be using the calculator here. And I'm going to go to second and then vars. I'm going to access to the distribution menu. Then I'm going to use inverse t, which is number 4. Enter. I'm going to plate the area, which is 0.05. So 0.05 here. The degree of freedom is 21. So I'm going to place 21 here. And that's basically all. I'm going to enter. And this is going to give me the t critical equals to minus 1.7207. So you want to round this one into 3 decimal places, so you're going to be minus 1.721. All right. The same thing from the other side, you're going to be 1.721. And one of them is positive, one of them is negative, so your numbers are these two critical numbers, right? Let's go and check it. So there are going to be two of them. One of them is negative 1.721, and the other one is going to be 1.721. Check it. Okay, that's great. Now we want to compute the t value. All right. So in order to do this, I am not going to use the formula from your chapter. However, I'm going to be using the calculator, which is very shortcut. So here I'm going to access to the tests first. So you're going to go to statistics, and you're going to go all the way to the right where you can see tests. So the test that you're going to be using is only one sample and t-test. So you're going to go to number 2. All right. And number 2 here, you're going to be asking you whether is it the data or statistics. All right. So if I go to statistics here, you're going to ask me about the X bar, the mean, the S, whatever numbers. I don't have the values here. And if I go to the data here, you're going to ask me, oh, the data is in L1 and the frequency and so forth. And this is what I'm going to be doing. All right. So I don't have the data in yet. So what I'm going to do, I'm going to enter the data. So let me show you how to enter the data, and then we're going to go back to the test, right? So let's quit here. All right, so how can I go and access to the list? So the list is located under Stat and Edit. So you want to go and edit the list. And usually the list, you have L1, L2, and so forth, right? So what I'm going to do, I'm going to enter all the numbers in. So there are 22 numbers. It's quite a work. So I'm going to pause here and then go back whenever I enter the data. So let me enter the first 2 numbers. So how do you enter this? This one, this highlighted, the first one, you're going to be 3, enter, and then 2, enter, 7, enter, and so forth. All right, let me pause the video, all right? Okay, so I am at entry number 21, which is 5. I'm going to put 5, enter, and then 2, enter. I am done literally with the list. All right. So now what I'm going to be doing, I'm going to go back to the test. So I'm going to go to stat. I'm going to go to test. I'm going to go to number 2, which is t-test, enter. So now I have the data, so I'm going to put what is mu0. All right, so mu0 is a 3.18. I'm comparing with 3.18. So 3.18 here. I'm going to put it into list 1. The frequency here, we don't have 2 frequency, we have only 1. So the frequency, every number is of a frequency 1. So we keep it as default 1, right? Now, for the mean, all right, so the hypothesis H0 will be, as you see it here, the mean is different than 3.118. So you can, if we have one tail, you can move it around, but we need it in here. All right, different sign. Enter. And then we're going to go and calculate. All right. Okay, so the calculation is done. And as you notice here, you are given right away the t value, which is really great. There is nothing else to do. So the t value, you can see it here, t equals to 1.5954. So t, if I round it, all right, to 3 decimal places, you're going to be 1.595. All right, so this should be the answer for the third question. Let's go and plug it in. And they want at least 3 decimal places. That's good. So 1.595 and check it. Okay, great, it's correct. Now we're gonna choose, make a decision and choose. Actually, we have everything in here. So what we're gonna do, this is what we call the t-test. And we're gonna play the t-test on the chart. So before placing the t-test on the chart, let me explain what the meaning of the critical values, right? Every time you have a critical values, you have a wall here and a wall here. It happened to be 2, so there are 2 walls. If you go for the direction of the alpha, this is you are rejecting H0. If you go from the direction of the alpha from here, you are rejecting H0 as well. All right. And if you fall between these two here, you are accepting or do not reject H0. So the not reject zone should be the middle in here, and the rejection zone it should be the side here or the side here. And now depending from the value test here where you're gonna fall, we're gonna make a decision, right? So if you notice here 1.595, you're gonna fall just right here, somewhere here. So this is a t-test, all right, and the value is 1.595. all right, so obviously you are within the green zone, which is you are accepting H0 or do not reject H0. all right, so that's how you make a decision. Okay, let's go back. We do not reject H0. Check the answer. Now we did not reject H0, right? So we collected the data, and this data figure out that we are not supposed to reject H0. What does mean? It means H0 is good. So if H0 is good, the H1 would be a bad, right? So it happened here that the claim is H1. So are we having enough evidence to support the claim? No, we don't have enough evidence to support the claim. All right. We try to collect the information. This is our evidence. We try to calculate and figure out whether maybe we're going to have a support for the claim, but it happened that this evidence is not a good evidence to support the claim. All right. So the question here, there is not enough evidence to support the claim, which is H1. All right. It happened to be H1. Let's see. And that's all. All right. I hope this will help.